So 3.7 ties into what we did in 3.6 in part. So I have this union versus intersection. I'm going to start, I used to do this at the end, but I found it works a little better to flip it at the beginning. So I'm going to fill in this chart. It's not going to make a ton of sense until we actually start doing some examples, but I found it makes more sense to put the chart at the beginning. So we're kind of tying what we did yesterday with absolute value. So I'm going to say if we have an absolute value with an x in there, and it could be absolute value of x plus 4, absolute value of 3x, or something like that, but absolute value with an x in there. If you have that being less than or equal to, so I'm going to do a little dash line under it just to kind of show it's like, well, it could be less than or it could be less than or equal to. The equal to isn't really significant, a number. So we did problems kind of like this before, right? But it was equal to. So now if we have less than, that's going to be intersection. So that's the first half of yesterday's notes. Anyone remember the word that went along with intersection? And. Nice. So you'll have that word and in there. So then in your answer, if it's a write out your answer, you should have this here, x is less than 7, and x is greater than 2 or something like that. But those was the inside range. So, or if you're looking at like a graph, this isn't really part of my notes, but it would be like where you have and you shade the inside. That's what I mean by the inside range. We're shading that inside part of the line. Fair enough? If we have that exact same sort of thing, but now we have a greater than, so if you have an absolute value with an x in it, and it's greater than a number, or I'm going to put the little dashes, or if it's absolute value with an x inside is greater than or equal to some number, then it's going to be the opposite one. It'll be union. And the word for union was or. And then the answer will be the outside range. So if that makes sense, don't bother with the picture, but you could have like open circles or closed circles, but we're shading the outside part. So something like that there. Is that fair? And that's kind of where we're going with the notes. How do we take and merge what we were doing with the absolute value with this union and intersection stuff from yesterday? So the steps that I have there are the exact same steps as before. First step is always isolate the absolute value, trying to get anything that's outside of there by itself. So this example here, you look, we move that 4 first. Fair enough? So you want it just to be absolute value. Then you break into 2 problems and solve, hold on. Need to figure out what word goes there. Break into 2 problems and flip the sign. Maybe I'll say flip the inequality for the negative one. Remember how if we divide, if you have an inequality, 5x, negative 5x is less than 2. If we divide both sides by negative 5, we had to flip that sign. Agreed? So the less than would become a greater than. And then we solve both. Okay, so here's my example. And I just, instead of taking the time to do that, I figured we'd work through one. So first step was, all right, isolate the absolute value. So this minus 4 has to go. So we add 4 to both sides. We get absolute value of 2x equals 14. Good? And then once we were here, if it was just a normal equation, so an equals, we break it into 2 parts. We solve both of them. We get our 2 answers. Yes? We're going to do that same exact thing now with inequalities, but when we have our, say, a less than here, the one that becomes negative, we have to change that to a greater than. Or if right here we had a greater than or equal to, this here would have to become less than or equal to. So it's really not too much new crazy stuff. It just takes a couple things combines them together. You just have to remember those little changes. All right, you ready? Example 2. First step is to? Perfect. Minus 2. So first thing we do is we isolate the absolute value. So I have absolute value then of 4x minus 1. And again, am I going to be bugging you to show your steps? Yes, because I try to be a good teacher. Some days I succeed more than others. All right, so we're here. Now, we have absolute value all by itself on that side, so now we break this baby up into 2. And when I do that, I get a 4x minus 1 is greater than or equal to 6. Now, do we put the word or and? That's going back to that chart. If it's greater than or equal to, we use the word or. So this will be an or. Then we go with what's inside again, 4x minus 1. You're just copying exactly what's on the inside. But we want to make this over here at the negative 6. So what do I have to put in between those? The other direction. So it starts out greater than or equal to. Because I'm making this side negative, it's kind of like dividing by a negative or multiplying by a negative. We have to flip the sign. Okay there? Now it's just what you've been doing for the last few days. Go through and just solve the thing. So add 1, add 1. I'm going to do both sides kind of at one time. So if I add 1 4 times there, so I get a 4x is greater than or equal to 7. Or 4x is less than or equal to negative 5. Last step then, we could divide everything by 4. I'm going to do that to both sides there. And come on. There we go. All right, now I can say, all right, my x's drop out. And I have x is greater than or equal to, should we just leave the fraction? You decimal people? We could do decimals, 1.75. That's what I like. If you had left it as 7 over 4, that's fine, you can't reduce it. Or x is less than or equal to negative 1.25. How you feeling on those? You know what, you love it? Probably should go through and quick graph it a second. So if we have a 1.75, that's the higher of the two because it's positive. And greater than or equal to means we do the filled in circle and shade that baby to the right. Then we have a negative 1.25. And x is less than or equal to, so the equal to means we do the closed, shade it to the left. All right, any questions on that? Things we should go over? We're good? All right, then, example 3. And then we have this possible shortcut, but most of you probably won't choose the possible shortcut, but it is cool. It's really cool. Okay, so absolute value is already isolated. Oh, no. What's up with that? Yeah, really, it's kind of brutal. But okay, x plus 4. X plus 4 is less than 7. Now, what word goes in the middle? And. Nice job, Owen. So because it's less than, it's going to be an intersection. It's going to be an and problem. And then we have a x plus 4 is greater than negative 7. So the one we make negative, we flip the sign. And a little bit fewer steps to the answer. We're just going to subtract 4 from everything. And if you do both sides kind of at one time, it helps you make sure you don't change the signs in the middle. We have a x is less than 3, and, so intersection, x is greater than negative 11. If we wanted to graph that thing, we'd have, all right, so we have a 3, and because it's x is less than, we do open circle, because it's not a or equal to, and that's going to be shaded to the left. X needs to go that direction. But x is also greater than negative 11, so I'm going to slap a negative 11 on there before I shade too far. Because it's greater than, not greater than or equal to. We do an open circle and we shade to the greater, so it's just the part in the middle. So if I'm giving you one of these, or when I give you one like this on the test, if you totally draw a blank on the and or the or part, you could go through to the solution. And then, because on the test, I'm probably going to give you some to graph, but I'm also going to give you some and just be looking for an answer like this form here, or that form there. So if you're not sure what word needs to go in there, you could always graph it. Because if these two are going away from each other, then you know it has to be or. It's going to be union. If they're going towards each other, then it has to be intersection, has to be and. Fair enough? In all honesty, and I maybe shouldn't tell you this, but in all honesty, I just do it that way. I don't use the shortcut. But here's the possible shortcut that you could do if you wanted to. This comes in handy probably most often if you get a picture of an inequality and say try to come up with what it's going to be. I don't know. Anywho, if you're trying to find what equation gives you this inequality rather than using this to solve equations. But if you have absolute value of x is less than a, that's going to give us a graph that looks something like this here. So we'll have two endpoints. There'll be open circles on them just because it's less than, not less than or equal to. And that one there is going to be shaded outside or inside with less than? Inside, because that's the intersection one. So say you have a graph something like this here. These numbers, the number there and there, are going to be related to this a value. So those numbers then are going to be, so this one here is going to be negative a, and this here is going to be positive a. But this only works if you have them being the same number, like a -5 and a 5. So we'll do the little bit harder one at the very bottom on page 3. So all right, this next one then is going to be a union because it's outside. So I'm going to do filled in circles now because we have the or equal to. So we're shading outwards. Filled in because it's or equal to. And then we'd have a -a and an a. So again, we'd have to have those being centered around 0. The one that's probably more helpful is going to be at the top of the next page because then it's going to work if it's not -5 and 5. What if you have instead a 5 and a 13 or something like that? So a is kind of like the distance from 0. Can I convince you of that? So this a here is this distance from 0. And maybe I'll say the -a is going to be the same distance, just other direction, still a away. So those are both going to be a, and maybe I'll even write them up above. So you have, not that way though. So you have an a and an a and an a. You could look at it that way. So the number that's at the end is going to be the distance away. So in this next one, my distance is going to be 4, agreed? So I could say this right here is going to be the distance from the center. Good? And then I tried kind of showing it right here that middle number is going to be what's paired with the x. But you'll notice the sign is always different. It's x minus the middle number. So if I have an x minus 9, that means the middle number of my shading is going to be positive 9. So we could start by saying, all right, I'm going to have a 9 right here in the middle. How far away from 9 am I going? 4, because that's kind of that a, that number that's by itself. So I go 9 plus 4 is 13. So I have a 13 here. 9 minus 4 is 5. So my endpoints are going to be at 5 and 13. You still tracking with me, kind of, sort of, mostly? Open circle, closed circle? Closed, because it's the or equal to. Now if it's less than or equal to, we do in the inside or the outside? Inside, that's a union. So then it's going to be like that. Yes? And if you wanted to, you could go through and label like 4 and 4. You could do something like that if you wanted to. But okay, this very bottom one, then we're done. Middle number is 2. Ooh, we fell for the trick. Not 5. Similar to 2, -2, because it's x minus the middle number. So x plus 2, you agree that's the same as x minus a -2? So the middle number is going to be x minus the middle. So that's the middle. So -2 is my middle. So it'll always be the opposite sign. If it's x minus the number's positive. If it's x plus the number's negative. Tell yourself math's just screwy, but there's a reason for it I could tell you later if you want. Okay, now we're going how many away? 5. So -2 plus 5, -2 minus 5. Plus 5 gives me 3. Minus 5 gives me -7. Open circle, closed circle? Open circle because it's just greater than, not greater than or equal to. And if it's greater than, we shade outwards. Yep, because it's union. So shade to the left, shade to the right. Stand up, sit down, fight, fight, fight. Okay, we're done. Questions? Yeah.